This timeline is trying to represent, as well as the title says, classical mechanics versus dimensional analysis. I should say a more geometric flavor of classical mechanics. Um, and so I just placed some landmarks on the timeline. I obviously begin at the beginning with the Principia, and then so we have a sort of a symbolic beginning of mechanics at Newton's, for example, and then we have some landmarks, Lagrange's, Hamilton's, Lee's, Wells for gauge theory, and then some reference for what is a modern understanding of classical mechanics, such as Marsden's or Arnold's, could be someone else's. The point here is that I want to emphasize sort of when a subject is sort of beginning, maturing, and being mathematically formalized roughly. I mean, these are very rough dates. And so the key takeaway from this timeline is the fact that um, dimensional analysis and mechanics are not in phase, right? So this is the main point of why I'm showing this timeline. So perhaps you're familiar with the top timeline, with the classical mechanics timeline. So let me briefly discuss the bottom timeline, which you might be less familiar with. So the bottom timeline is outlining some contributions towards the theory of dimensional analysis, modern dimensional analysis. So of course, both mechanics and dimensional analysis go back to the beginnings of science thousands of years ago. But in its modern incarnation, I think it's fair to say that these are sort of the main moments that, or the main publications that contributed to the current history. So we have a first mention in Euler's theory for rigid solids. But the first systematic presentation of dimensional analysis as we know it today happens in Fourier theory of analytical theory of heat, right? His sort of landmark thermodynamics book. Um, so the subject really starts there as we know it today, and it begins maturing until, so it has contributions from Rayleigh. He has a full chapter dedicated to dimensional analysis, and I think the name is already being used in this way, the theory of dimensions, or the method of dimensions, or something like that, he calls it. And then we have the pi theorem, so the celebrated result where you can identify the minimal dimensionless parameters of a given physical theory characterized by some equations involving dimensioned magnitudes. It was popularized, proved and popularized by Buckingham in I think it was 1914. Around that time, there was also some papers in Nature that launched the theorem into the mainstream. I mean, the theorem had been already pointed out by Rayleigh, although without a full proof, and had been fully proven by another French mathematician before. But at any rate, around the time of Buckingham's publications, at the beginning of the 20th century, we have the sort of the mature phase of dimensional analysis. So what I want to emphasize here is that by the time that mechanics is reaching its maturity, we have the beginnings of a systematic treatment of physical quantity and dimensional analysis as we know it today. And as a reference for dates, it was around the time when Einstein published his general theory of relativity that we have the launch into the mainstream of dimensional analysis. So that's how different the story of classical mechanics and dimensional analysis is from a historical point of view. And then into the 20th century, we have I mean, I always like to think of history as a logarithmic scale, both in terms of resolution of our understanding and probably in regards to science for the pace of development. But as we get into the 20th century, it might look like the formalization of mechanics and the formalization of dimensional analysis are close, but I would say that logarithmically they are equally separate from the previous sort of out of phase or sort of misalignment of the two subjects. So we have around the 70s with where all the differential geometry was sort of coming into its own, and all the geometric mechanics. Dimensional analysis was still being discussed, and being some work was being done precisely by Hart, but nothing mainstream or nothing well understood was out there for people to use. And then finally, in the last few years, there were a few publications from Vitolo and collaborators who proposed their theory of positive spaces and semi-vector spaces, and in my opinion, that basically mathematically captures in full rigor what dimensional analysis is. So we have a good mathematical theory of dimensional analysis.